On May the 26th, 1960, American Ambassador Henry Cabot Lodge shocked the United Nations by exhibiting a miniature room bug that had been discovered in the US Embassy in Moscow. It was the dramatic high point of several years of Cold War suspicions between Eastern and Western Bloc nations, where each side kept accusing the other of spying on their respective diplomatic corps. The bug, also known as the Thing, that Lodge revealed to the United Nations had been secreted in the Great Seal, which had been hanging over the ambassador's desk and was a gift from the Soviets. As Lodge revealed his tale of intrigue, it turned out that the US had discovered the listening device in 1952, but didn't reveal its existence for 8 years. During those 8 years, the US government decided to conduct exhaustive investigations within other embassies, missions, and consulates maintained in other nations. The search turned up about 130 additional secret eavesdropping devices, but none gave quite the same emotional shock as that first one discovered in Moscow, and none were as cleverly designed as the Moscow bug. The eavesdropping device shown by Lodge was one of the first covert listening devices, or bugs, to use passive techniques to transmit an audio signal. It was designed by Soviet-Russian inventor Leon Theremin, best known for his invention of the theremin. It consisted of a cylinder about as big around as a quarter and measuring 17.4mm from front to back. A 9-inch rod protruded from one side, and on the front of the cylinder was a perforated cover incorporating a diaphragm. In operation, the bug was hidden within a cavity between the front and back sections of the Great Seal, which was made of maple. Just below the beak of the eagle were several tiny holes drilled to coincide with the location of the diaphragm. Those holes let in sound waves. Though by today's standards this bug was somewhat large and cumbersome, it performed the same task and operated with the identical theory of operation. The purpose of a room bug is to convert acoustic energy into electrical energy so that the information, speech, can be sent via wire or radio signal to a listening post. The Great Seal device used the radio method in a manner so simple that it amazed technicians of the day. It had no circuit as such, and since the Soviets wouldn't be able to continually change the unit's battery in order to keep it going, it had to be designed without any power source. In the 1950s, this was a pretty tall order. The Moscow bug, which was constructed of copper that had been silver-plated, was hollowed out inside to such close tolerances that it created a sharply tuned, so-called high-Q cavity. The State Department's intelligence service had estimated the Q factor to be as high as 1,000. Mounted on the rear of the cavity was an electrode or tuning post holding a 1/4-inch wide flat plate parallel to the 3mm diaphragm. The tuning post plate and diaphragm were capacity coupled. The 9-inch antenna, a silver-plated copper rod, passed through one wall of the cylinder and terminated in a small plate that was located near the tuning post. The monopole antenna was a quarter wave for 330 MHz, but was also able to act as a half wave at 660 MHz or a full wave at 1320 MHz. The post and antenna plate were also capacity coupled. The back cover was threaded for precise adjustment of cavity size. In actual operation, the Soviets placed a transmitter with a directional antenna at a nearby spot. Out of that transmitter came a signal at about 1600 MHz. The antenna was probably a small dish type, like a radar dish, and the signal was also radar-like except that it wasn't pulsed. The RF beam struck the bug's small antenna and a feeble signal echoed back. As long as the antenna kept the same electrical length, the echo would remain at the same frequency. Any person who spoke near the Great Seal generated sound waves that struck the bug's diaphragm, causing it to vibrate. This altered the cavity's size ever so slightly and varied the capacitive values of the device. The changes in the capacitance altered the charge on the antenna rod radiated to it from the transmitter and caused its echoed signal to vary accordingly. In effect, the bug modulated a small piece of the beam's signal before returning it as an echo. The echo was picked up by a receiver and demodulated to reproduce the sound of the original speech. At the time, the State Department observed that the bug was especially difficult to detect because its power was controlled by the eavesdropper. They likened the device to the echo boxes that were once placed in front of radar units to tune them. The entire bug weighed just over 1 ounce, and its cavity had an inductance of 1/100th of a microhenry. In the 8 years after the bug was discovered, it was put through many tests by electronic experts. They reported that it worked well in free space, but was extremely sensitive to its environment. It must have caused the Soviets some headaches once in a while because its operation was so critical. It went haywire when any small piece of metal, i.e. a nail, a wristwatch, a tie clip, or even a pair of shoes, was placed near it. The thing was discovered accidentally in 1951 by a British radio operator at the British Embassy who overheard American conversations on an open Soviet Air Force radio channel as the Soviets were beaming radio waves at the ambassador's office from a block across the street. An American State Department employee was then able to reproduce the result using an untuned wideband receiver with a simple diode detector, similar to those found in some field strength meters. The State Department conducted a counter-surveillance sweep of the ambassador's office using a signal generator and a receiver in a setup that generated an audio feedback if the sound from the room was transmitted on a given frequency. During this sweep, they found the device in the Great Seal carving. The FBI, the CIA, the Naval Research Laboratory, and other US agencies studied the device as part of an investigation involving the British MI5 and a technician from the Marconi Company. They managed to get the thing working on 800 MHz. The membrane of the bug was extremely thin and was damaged during handling by the Americans, so the Marconi technician had to replace it. The simplicity of the device caused some initial confusion during its analysis. The antenna and resonator had several resonant frequencies in addition to its main one, and the modulation was partially both AM and FM. As the years went on, bugs became much smaller and techniques for using them became highly sophisticated. They made the Moscow bug look extremely primitive. US foreign buildings were still vulnerable to being bugged because they were often built by local workmen who could easily fill the whole structure with listening devices that could take years to unearth, especially those that lie dormant until triggered into action upon receipt of a command signal. Of course, methods of detecting bugs or taking countermeasures against the effectiveness of those not yet located also came a long way. The most basic countermeasure against a room bug was setting up a barrage of noise which would confound the listening device while a conversation was taking place. This could consist of a radio or tape machine playing the sound of running water or an electric fan. Even though a clever professional eavesdropper could eventually figure out how to filter out these noises, there would be considerable difficulty in getting a good copy. The best masking method was to drown out the bug with a radio or TV playing a talk program, so if the eavesdropper tried to filter out the frequencies of the masking sounds, they'd also have to filter out the voices in the conversation he wanted to hear. Another method used to foil undiscovered room bugs included attaching vibrators, or buzzers to the walls of a room. An illegal method would include establishing a hash transmitter, a broadband RF device that would send out a signal over a wide range of frequencies in order to jam bugging receivers. The problem with this is that it would often cause interference to the radios and TVs of everybody having the misfortune of being located anywhere near the hash transmitter. One later method of bugging a room was in many ways a redefinement of the 1952 Soviet idea. This system bounced a laser beam at a window pane. Sound from within the room in which the window was located vibrated the window sufficiently to cause the laser beam's reflected beam to become modulated so that the conversation could be retrieved. Of course, the only effective way of avoiding undiscovered room bugs is to avoid talking about anything you don't want overheard, or at least using a pad and pencil to write it out.